Hi folks, today we're going to work on operations with functions. Now this is going to kind of extend what we've already talked about with combining like terms and things of that nature. So just working on these operations. The operations, what I'm talking about is just plus, minus, multiply, divide. So this first example, it's just asking us to take f of x and add g of x. Well, up here, here's f of x, here's g of x. So we're just going to substitute in, and we're going to figure those things out. So f of x is 4x to the 1/2. G of x is negative 9x to the 1/2. And it says to add those two. So we can combine those like terms because they're both x to the 1/2. So put our coefficients together, 4 plus negative 9, that's negative 5. So negative 5x to the 1/2. Now, to talk about the domain. Basically what the domain is if you think back to domain and range, domain was your x values. So what does x equal? What can x be and what can it not be? Well, if we think about what x to the 1/2 means, what it really means is the square root of x. So what we have in essence is negative 5 times the square root of x. So given that information, what can x be and what can it not be? I like to think of it in three terms. Can it be positive, negative, 0? So in this case, we probably shouldn't take the square root of a negative because that's, as you know, going to give us imaginary numbers. So x cannot be negative in this case. It can be 0, it can be positive. So our domain on this is just going to be x is greater than or equal to 0. There's our domain. So our answer is here, our domain is here. Moving on to the next one, we're subtracting f of x minus g of x. It's asking for that specific order, so we just go 4x to the 1/2 minus negative 9x to the 1/2. So here, minus a negative, we are going to add those, so we have 4 plus 9 is 13, x to the 1/2. And again, that's finished. That's done. Now, for the domain, we think about it in the same thought process that we thought about that one over there. X to the 1/2 means square root of x. So we can't use negatives on that or we'll get imaginary numbers. So we can use zeros, we can use positives. So our domain on this, x, must be greater than or equal to 0. There's our domain. Here we're going to take the same f of x, the same g of x, but this time we're going to multiply and divide. So more operations, but with the same function. So this first one, f of x times g of x. So we just do that. We have 4x to the 1/2 power times negative 9x to the 1/2 power. So we can multiply those. 4 times negative 9, well, that's negative 36. And we think about what to do with the exponents, x to the 1/2, x to the 1/2, same base numbers, they're being multiplied, so we can add those exponents. So negative 36x. Now, the domain for this, what can x be, what can it not be? Can it be negative? Can it be 0? Can it be positive? Yes to all the above. So our answer to this would be all real numbers. And a short way of writing that is just kind of a double line R. So there's our answer. The next one, f of x divided by g of x. So we substitute in 4x to the 1/2 divided by negative 9x to the 1/2. So now we're dividing, and we can break that up so we're working two individual small problems. 4 over negative 9, that's just going to stay as negative 4/9. Doesn't matter where the negative is, as long as it's there. X to the 1/2, x to the 1/2 on top and bottom, they're just going to divide each other out. So they're done, they're gone. So here's our answer. Now, with no x as part of our answer, we're just going to say that x can be anything. All real numbers. There's our answer. Now, if we look back to the initial part of the problem, you'll notice that there are x's in there, and those could certainly have some restrictions on them, but as part of our final answer, it does not. So that is done. All real numbers are this part of the solution. So go ahead and practice this on page 432, numbers 3 through 19. The domain might take you a little bit of time to get used to, but the actual operations themselves shouldn't take much time. So best of luck to you. We'll see you in class.